Welcome to your first flip video. It's called Understanding the Cause of the Motion of an Object. All right, so what you will do is as I go through these slides, you will simply be filling in information on the note sheet that you have in front of you. Okay, so the essential question and objectives that we're trying to answer within this unit. How can I explain the causes of the motion of an object? It could be anything. We could be talking about a basketball. We could talk about a car. We could be talking about you as a person. How do we explain what causes the motions that you see in all of those things? Okay, the objective is called 7.P.1.2, and it reads like this: explain the effects of balanced and unbalanced forces acting on an object. The ones we're going to talk about are going to include friction, gravity, and magnets, even though we will not get to magnets necessarily before we track out. Okay, well, where did all this idea come from? It came from this cat right here, Sir Isaac Newton. He's got nice hair. A couple things about him that you need to be made aware of. First of all, he's English. He came from the United Kingdom. He discovered the laws of gravity. There are 3 laws of motion that he is famous for, and he's, kind of a big deal. I mean, he has the word sir in front of him. So here is his first law, all right, and here is how it reads. An object at rest, which means it's not moving, will stay at rest, or an object in motion stays in motion in the same direction and at the same speed unless acted upon by an unbalanced force. All right, so that's a lot to try to wrap our heads around. So let's look at some examples so we understand what we're talking about. Okay, this is also called the law of inertia. All right, that's a key vocabulary word right here, the law of inertia. So here are some real life examples of this first law. Okay, a soccer ball. You could have a soccer ball out on the playground sitting on the field. That soccer ball will stay there forever unless it's acted upon by an unbalanced force. The wind blowing it, you going over and kicking it will cause that soccer ball to have motion. All right, once you kick the soccer ball, it will move at a constant speed and in a direction forever until forces act upon it. Friction, gravity, those sort of things. Okay, game of tug of war, same thing. Both teams are pulling against each other, all right? That rope may never move and they just might be standing there not in motion because the forces are balanced. When one team gains strength and momentum, that's when you get an unbalanced force causing one team to move one way or another. Okay? Why do objects in motion not just keep moving forever? All right? And I talked about it a little bit with that soccer ball. All right? Things don't keep moving because there's almost always an unbalanced force acting upon it. Typically, those unbalanced forces are gravity and friction. Okay? If we have a book sliding across the table, if I push a book across the table, it'll move so far, but friction will cause it to stop moving. If I push it really hard and it goes all the way across the table, friction didn't slow it down or make it stop. All right? Once it leaves the table, gravity takes over and pulls it to the floor. Okay? Throwing a ball up in the air. I'd love to be able to throw a ball up in the air and have it go on forever and ever and ever and ever. It's not going to happen because we have gravity on our planet, and gravity is an unbalanced force that pulls that ball back down to Earth. Okay? There are a lot of forces that I'm talking about in this first law that we cannot see. Okay? And they're all forces that we refer to as friction, and there are lots of different kinds of friction forces. The first one, sliding friction. If you think about ice skating, sliding or gliding across the ice, the friction is between the blade and the ice. Rolling friction. If I go bowling and I roll the ball down the lane, there's friction acting against the ball, which will slow it down and actually change its direction. Fluid friction. This is air or water resistance. All right, if you are running and it's really windy and you're running into the wind, it's actually slowing you down. If you're running with the wind to your back, it is actually helping you and making you go faster. Okay? Static friction. All right, and I apologize, my camera is cut off the end of this. Static friction is initial friction when moving an object. Okay, so for example, if I were to pick up my laptop off the table, there is going to be friction that's going to make that job a little harder. Not impossible, because you never feel like when you pick something up that it's being pulled down by the table, but there is a little bit of friction just with the movement of any object in relationship to another. Okay, so now we're on to Newton's second law. All right, and here is how it reads. The net force of an object is equal to the product, okay, so we're talking about math, of its mass and acceleration. And if we were to write that into a mass equation, we have force equals mass times acceleration, because we're using the word product. Okay? 3 examples I have listed here. The harder a baseball is hit, the faster it will travel. So the force that I exert on a baseball, all right, and its mass can cause it to accelerate faster. If I am accelerating a car, I'm hitting the gas pedal, all right, the mass of the car doesn't change. I'm making this number in the equation larger, which if I'm multiplying those 2 things together, my answer will be bigger. Okay, as opposed to if I'm braking or decelerating a car, I'm hitting the brakes, the acceleration will go down, multiplied together, which will make the force lower. If I'm driving a loaded truck full of, wood in the back of the truck versus a truck that's empty, all right, the loaded truck is going to exert more force because it has more mass, all right, versus the empty truck, that mass is going to be less, which means its force will be less. All right, and finally, Newton's third law. All right, in Newton's third law, this is my favorite of all the laws. For every action, there is an equal and opposite reaction. All right, forces are always paired. Okay, and I have 2 examples here for you. First of all, when you sit in a chair, right now I'm sitting in a chair. I am exerting a force down on the chair, and the chair is exerting a force up on me. All right, so for every action, me sitting down, the chair has a reaction pushing me up. If they weren't that way, as soon as I sat in the chair, I'd fall on the floor. Okay? Same thing, hitting a nail with a hammer. All right, if I were to take a hammer and hit a nail, the force is hitting the nail. The nail is actually putting a force back on the hammer, which is why we hear that sound. All right, and so for every action, there is an equal and opposite reaction. And that is our first flip video lesson for 7th grade physics unit.